In this lesson we're going to be looking at some quadratic factorization. Now in the last lesson we were looking at, we went through the fundamental theorem of algebra and the factor theorem. Both of these are probably fairly new concepts to you, but what I intend to do in this lesson is build on some work that you should already know from other maths classes and show you how it already relates to the factor theorem which we just looked at. So let's play around with some polynomials to begin with. Let's consider the example PZ. So I'm using, because we're going to be doing complex numbers here, I'm going to use the variable z. Well, eventually we'll use complex numbers. Z squared minus z minus 6. Now if this was a year 9 or 10 maths class, you'd be looking at factorising this particular polynomial. Now to factorise this polynomial in a lower year level, you would probably use what I call the cross method. Now there's a number of different ways of setting this out, but this is the way that that I use. On this side of my cross, I write the factors of z squared. So z multiplied by z gives you z squared. On this side of the cross, I need to write the factors of negative 6. The factors of negative 6. Now, we could have 6 and 1. We could have 3 and 2. So let me put 3 and 2. Now, they are factors of positive 6 at the moment. So to get a negative 6 out of it, I need one of them at least to be a negative. If we just have a guess and we make the 2 negative, then we work out whether we've done that right. To work out whether we've done it right, we multiply across here and we'll get negative 2z. Multiply across here and we'll get plus 3z. Then we simplify that. What is negative 2z plus 3z? Well, that's going to give me positive 1z, which isn't what our middle term was. So I know that I actually got that wrong, so I can put a neat line through it, and with a bit of inspection and a bit of practice from the past, I'd imagine, you'll realise that if we make it a negative 3 and a positive 2, now multiply across, we'll get 2z minus 3z equals negative z, which is our middle term, so this is correct. So therefore my factors, and I read my factors across like this, as z take away 3 brackets z plus 2. This multiplying across business that we were doing here is really what we're doing when we expand these brackets. Just watch for a moment. As we expand these brackets, z times z gives you z squared. The negative 3 times the positive 2 gives you the negative 6. Okay, that was what we did, the z and the negative 3 and the 2 here. But the middle term that we want to make sure we got right comes from the negative 3 times a z and the 2 times a z. When we expand this to distributive law, we'll get negative 3z multiplying. That's what we had here. And we got positive 2z multiplying there. So you can see that's where this multiplying across and checking your middle term, that's where that comes from. Okay, so what we've got now is that p of z is factorized. Now that's all we needed to do, but I just want to make a couple of points relating back to the factor theorem. Z minus 3 is a factor. Z plus 2 is also a factor. Let's have a little bit of a play here. What does P of 3 equal? P of 3 equals means replace all the z's with 3's. That will give us 3 minus 3 brackets 3 plus 2. P of 3 minus 3 is 0 multiplied by 5 equals 0. So notice that P of 3 was equal to 0. What was the factor? The factor was z minus 3. Let's also try p of negative 2. P of negative 2 will equal, sub in negative 2 take 3, brackets, negative 2 plus 2 equals negative 5 multiplied by 0 equals 0. So P of negative 2 equals 0. P of 3 equals 0. In the previous lesson, we said that if P of A equals 0, then Z minus A is a factor. So here we've got P of 3 equals 0. So let's just see if it works. If P of 3 equals 0, factor theorem says that Z minus 3 is a factor. And sure enough, we see that it was. So that's true. We also, if we apply this, if P of negative 2 equals 0, factor theorem says that Z minus, it says if P of A equals 0, then Z minus A, so Z minus A is negative 2, is a factor. What's Z minus negative 2? That's really Z plus 2. Was Z plus 2 a factor of our polynomial? Yeah. So we can see that factor theorem is certainly true for this particular example. Okay, let's have a look at one more example. Let's look at PZ equals z squared minus 6z plus 5. Okay, so if we're in year 9, we would do cross method to factorize this. The factors of z squared are z and z. The factors of positive 5, and you've got to keep this as a bit of an inkling here, the factors of 5 are 5 and 1. Let's just check in our heads. Does that make sense? Does that work with our middle term? That would give us 1z plus 5z, which would give us 6z, positive 6z. That's not what we wanted. So we might say, the other factors of 5, positive 5, are actually a negative and a negative. Negative times a negative does give us the positive. So now we check our middle term, we'll get negative z minus 5z equals negative 6z. So yes, that's correct. That does give us our middle term. These are factors of 5 and these are factors of z squared. So our factors now are z take away 5 and z take away 1. Let's just see if factor theorem works here. Try P of 5. If try P of 5 will equal 5 take away 5, sub in 5, take away 5, 5 take away, 1, equals 0 times 4, which is obviously going to be 0. So since P of 5 equals 0, then z minus 5 is a factor. Notice the signs are always opposite because it's z minus a is a factor. Same with P of 1. If you look at P of 1, then you'll get 1 minus 1 here, which will give you 0. Who cares what that one is? P of 1 equals 0. Z minus 1 is a factor. Now I know in this example we had already factorized, so there was kind of no point in doing this as far as this problem was concerned. The reason I've done this is because I'm trying to show you that some of the basic maths that you did in the past is actually reinforced or is backed up by, it's consistent with the maths you're learning now in terms of factor theorem. Just as a final bit of proof with this, what if we actually said, you know, randomly we said, oh well, what's p of 2? Here's our polynomial, this one here, p of 2. What does p of 2 equal? P of 2 will equal, we can sub it in either there or here, p of 2 will equal 2 minus 5 multiplied by 2 minus 1. That'll give us negative 3 multiplied by 1, which is negative 3. Is that any use to us in terms of factor theorem? No, because factor theorem says if p of a equals 0. Back on this sheet. If p of a equals 0, then x minus a is a factor. So here, p of 2 didn't equal 0. So all that tells us is that z minus 2 in this case is obviously not a factor. Big deal. We knew it wasn't, but that's what would happen if it wasn't a factor. Then we wouldn't get 0 there. Okay, so that's a little bit of background on factorising quadratics. We will apply this process in a little bit more depth in a couple of lessons' time.